So at MiroMatrix, our mission is to eliminate the organ transplant waiting list by bioengineering transplantable organs. And the whole premise around the technology is the ability to take an existing organ, in this case a pig organ, cannulate it, and perfuse a mild detergent through it. Leaves you with the perfect scaffold of the organ itself. Then to infuse that or recellularize that with human cells.
So MiroMatrix, I think one of the things that's really fascinating about it is we're a mission-driven organization. So today there's over 100,000 patients on the organ transplant waiting list, and at least 70,000 of those patients are going to be screened for an organ. They're waiting, they need this life-saving transplant, and they're going to find out this year that they are not going to be able to receive one.
The only real solution that we see going forward for this is a new source of organs, bioengineered organs. So that's a kidney. What you see here is just the white extracellular matrix. This is a technical term for it. So if I get it to rotate around, eventually you can see the aortic valve there. This is a big heart. So these are all pig organs. They were able to decellularize. It started as the VP of R&D and then, transitioned in 2017 to the CEO, took the company public on NASDAQ in 2021, and then was acquired by United Therapeutics in 2023. Being acquired by UT was almost a feeling of coming home. I mean, if you look at our core values, if you look at how we operate, it was very similar in terms of a cultural standpoint. It's a great fit. There's a ton of support. And it really enables and allows us to even go at a more rapid speed to get this ultimately to where it matters, and that's the patients.
There's so much potential in our technology. The immediate effect on any patients with acute liver failure is imminent. But eventually, as we work towards our implantable human kidney and livers, we'll be addressing 95% of the human organ transplant waiting list by providing a scalable source of those organs. That'll open up a pathway to pursue other organs on that transplant waiting list. The other 5%, heart, lung, pancreas, the options are limitless.
We talk about being pioneers in this space, and for us, we achieved something no one else had ever done before. Nobody has ever gotten a bioengineered organ cleared by the FDA to initiate a phase 1 clinical study. This is just a plaque commemorating that we were the first ever to get an IND cleared by the FDA and a 1271 exemption. This allows us to start our phase 1 clinical study. This is allowing us to get to that next phase that nobody's been able to achieve. We now demonstrated it's possible, and this allows us to go forward. And what we were able to get over that hurdle is through data and through good science and good reports, able to present to the FDA all of our data to allow them to give us our IND clearance to start our first human clinical study.
We are about to change medicine. We're about to change the way patients experience transplantation. The world just doesn't know it yet, that we're able to be on that brink of that change. And it's just incredibly exciting.
Day to day, it's really leading teams. How do you build strong teams? Who enjoys the challenge? Who enjoys solving the hard problems? Because on the backside of that, that's where you see the growth. We've been deliberate to really create a company culture that's really open to ideas, open to innovation, and driving these problems forward. I think a lot of the people and staff at MiroMatrix, if you look at some of their hobbies, they enjoy building stuff, they enjoy creating stuff, because we're harnessing that same energy that they naturally do and applying it towards this big problem. And by getting a group of those individuals together, they become incredibly powerful. I can't think of a greater mission or a greater problem to solve, that there's not a larger unmet need today than the organ transplant waiting list.
When our technology is in place, we would be able to say, if this patient needs an organ, we start going through our pool of cryopreserved cells, find a cell line that works for this patient, and grow their organ on demand. So we would have an organ ready for them within weeks.
What we're doing is hard. Nobody's done it before. But the significance and importance of it is massive. And now we're on the forefront of having that impact that we've always searched for.